Hello everyone, welcome back to our Hyperledger Besu development series. In this tutorial, we are going to see how to set up a private network using IBFT 2.0 consensus. This is for development purpose only. Don't use this tutorial for production. We are just following official documentation. We must have installed Besu on our system for this tutorial. Let's follow the steps. In our first step, we have to create directories, multiple directories, node 1 to node 4, and one common data folder in all directories. I have already created this folder structure. You can see where data folder is common in all directories. Let's go to the second step. Here we have to create one IBFT config file .json. So let's create it. IBFT config.json. We have to just copy this code and paste it in that JSON file. Here you can see all the details, chain ID, which engine we are running on this node IBFT2. Here you can see all the addresses and its data like address, private key, and its allocated balance. We have that addresses. Let's go to the next step. Here we have to create node keys and genesis file. So for that, copy this command, redirect to our main directory in our VS Code, which is a IBFT directory. Let's redirect to IBFT folder and paste that command. It will generate keys and genesis file. In our directory, here you can see network files are there. Inside it, 4 addresses are there: key and key.pub for all 4 addresses. Genesis file is also there. Here you can check chain ID, engine, and you can see here extra part, extra data. As we are using PoE network, we must have to add extra data. Here you can see, you can check the addresses, common addresses in our extra data. It is from our recently we have created those addresses. It is those addresses. We can check. We can just copy this address and let's find it in a Genesis file. Here you can see maybe some problem is there. Okay, yeah, we have to remove 0x, and now you can see this available address is available in our extra data. Similarly for remaining 3 addresses. So let's go to the documentation. Here you can see we have to add that key and pub file in our main directory, data directory. So let's just copy this key files to our respective directory, data directory. So let's do it. Let's copy keys file from network files. Either we can move those files or copy those files. Similarly for other directories also, let's move these key files in second data directory. Same for third directory, and yeah, and for last directory also. Here we have shifted all key files in our respective directories. Let's go to the next step. First we have to move this genesis file in our main directory. Now we can delete this folder. It is not useful for us now. Just delete this folder. Let's go to the next step. Here we have to simply copy this command from here to start first node. For that, redirect to our first node directory. Just clear the console. Redirect to the node 1 directory. Similarly for all other nodes, node 2, node 3 and node 4. So let's cd IBFT node 2, get one more terminal for node 3, and same for node 4. Yeah, so just to the documentation and copy this command. Before that, if you want to query data using get console, so we have to add one extra API in our command, so we can query the node data in our using get console. So let's copy this command and paste it in our first terminal. Enter. Here you can see our first node is initialized. This is an unique node ID of this particular node. Let's do it for second node. We have to do some modification in our command, where we have to enter the enode URL of first node in the command. So let's copy this enode from our terminal 1 and paste it in here, node 1 enode URL. Before that, we can do it for all commands at the same time. So let's copy command for node 3 and node 4 as well. In all commands we have to just replace node 1, so let's copy node 4 command also. Here here we have to replace our node 1 enode URL, so we can do it globally for all commands. Just copy this enode URL from our terminal and replace it in all three commands. Let's copy first command for node 2, paste it. Here you can see second node is also initialized. Same for third node, and same for last node. Yeah. So here you can see enode URL of all node are unique. Each node have unique enode URL. All nodes are initialized and looking for the peer connection. As we have added enode in our command, so it will automatically get in a peer-to-peer connection. Sometime it will take some time, but yeah, here you can see in our console uh, those all nodes are in connection and blocks are started. Here you can see in all terminals block imported block imported and produced. So let's verify whether our network is working or not. In our last step, here you can see a curl command. By this we can, if you get response by this, that means our network is working perfectly. Here you can see same response we are getting in our terminal as well. So let's see the node data in our Metamask as well. So for that we need RPC URL. So let's add this network manually in our Metamask. Paste RPC URL of first node. We have to add a http:// as it is local node. It is saying network is already there. Okay, let's see. We have to delete that previous network, or we can use the same. Let's try to do transaction. For set we have to import this test address in our Metamask, so we can import that private key, that account using private key. Here it is showing some error, maybe let's see. Let's try with the another private key. Maybe yeah. Here you can see the allocated balance. We had allocated this much balance in our Genesis file itself. Let's do a transaction. This is our light EVM compatible blockchain explorer. It supports all EVM compatible blockchains, so we can verify the block number as well. The same block number in terminal and same block number this explorer also showing. So let's transfer some funds to another account. Okay, transaction is getting rejected. Let's check what is problem. We'll try it once again. Gas estimation is working. Let's see. Okay, again same problem. Let's check our network. It is on our test network only. Let's clear the log data from advanced setting. Let's try. Okay, same problem again. Let's check the logs in our VS Code. Logs are perfect. I think there is problem in Metamask only. I think we have to remove that previous network from Metamask, clean it again, and again install Again add that it is our again add this custom network in our MetaMask wallet. So let's go to the setting. Add network. We have to copy it from this command Besu test node RPC URL. Again it is showing you have test network. Let me check what is the problem. Okay, I think network is already there in our MetaMask. Okay, it is available in test network. Just delete it from here. Now we can try it again. Let's press this page. Yeah, now it is working, I think. So Besu test local chain ID, it will automatically fetch the chain ID. Yeah, just copy this chain ID to add some symbol. Test is okay. Let's switch to our local Besu node. Yeah, here you can see available balance. Let's try the transaction again. Now Explorer is also showing block data. Let's transfer one token to some another address. Maybe it will work this time. Before doing transaction, just clear this previous logs from MetaMask, from advanced setting. Clear activity data. Let's try transaction now. I think it will work now. Okay, let's check the logs. Yeah, it is done. Here you can see our transaction value is one token. That's all for this video, guys. In our next video we are going to learn how to set up an Besu private network using IBFT consensus. Thank you. Do like, share and subscribe our channel. Thank you.